Hi, this is Can Erciyer. In this video, I'm going to show you how I did my course finishing project called Automated Board Cleaner with Remote Controller for my Introduction to Electrical and Electronics Engineering course. I used Arduino microcontroller board for controlling the electronic components in my project. And the second main component is 6-volt DC motor with high torque for moving the mechanism that I built. And the DC motor needs a motor driver for maintaining stabilized power. I use DRV8833 motor driver. It can drive two motors at the same time. I used two 3-volt battery holders and I connected them in serial to achieve 6 volts, which is the power that the DC motor needs. This is the 433 MHz receiver module. It's for to trigger the mechanism when I press on the remote controller. These are the wooden plates for creating the slider, which is going to slide on the board to clean the surface. Dimensions for the smaller ones are 4 by 4 by 1 centimeters, and for the bigger one 12 by 4 by 1 centimeters. Now I'm going to remove the eraser side from board eraser and I'm gonna stick it on wooden plate. Now I'm determining the center of the wooden plate by measuring it for placing the bolt nut exactly on the middle. Now I'm sticking the board on the wooden plate that I cut it with my dad for 3 hours with a manual saw because we didn't have anything else to cut it. Now I'm removing the middle part of the gear so the bolt can go through it and I can make the bolt spin around itself with the DC motor that connected to bolt with gears. And here I'm showing how the mechanism should work. I need to solder some male headers to my Arduino so it can attach to female headers on the board. Time for the solder female headers on the board. From now on, I'm gonna call it motherboard. Now I'm soldering the receiver module and I'm just gonna solder 3 pins of the module. One is the ground pin, other one is the 5-volt pin, And the last one is the D0 pin, which is the data pin for the module. And one data pin is going to be enough for the project because I'm going to use just one button of the remote controller. Soldering the motor driver is easy as soldering the receiver module. One side of the motor driver's pins are for the connect to Arduino, and other side is for the connect external power source and the DC motor. Now I'm creating a path from Arduino's ground pin to both motor driver and receiver's ground pin using a soldering iron. Now it's time for the same thing with the 5-volt pin. Now I'm soldering the two data pins of the motor driver to Arduino's second and the third digital pin. And data pin of the receiver module goes to digital pin number 4 of the Arduino. Now I'm sticking battery holders on the motherboard using hot glue. After the sticking process, I'm going to solder them in serial, which means I'm going to solder one of the battery holders ground cable to other's 3-volt cable. Now I have 6 volts, and this 6 volts going to motor driver's external power source pins. I have soldered cables onto the DC motor, but unfortunately I couldn't take a video of it. Now it's time for connecting DC motor to motor driver. It's time for the coding part. First of all, let's define the pins. M1 and M2 is the motor pins that is connected to second and third of the Arduino pins. RC, as in receiver, is connected to digital pin number 4. And let's define an integer. VLE, as in value, is for the value that we get from the receiver. Let's determine the mode of the pins by using pinMod command. M1 and M2 is going to be output pin and RC pin is going to be input. When I press the button on the remote controller, RC value is gonna be 1. When I press off on the button, RC value gonna be 0. That's it for our setup. Let's continue on the loop. VLE is going to equal to the RC value, so we can read the value of the RC pin, 0 or 1. Let's create a if loop. When value is equals to 1, M1 pin is going to be high value, which means gonna get 5 volts. And M2 value is gonna be low, which means 0 volts. And that means motor gonna spin and move the slider to the opposite side. And this movement will be for 28.5 seconds. I have tested it and it took 28.5 seconds to reach to the opposite side. After the 28 seconds, it is going to be to the reverse and it is gonna come back to its first point, start point, after 28.5 seconds. After all of that, it is going to reset itself and will stay at its position waiting for another trigger from the receiver. After fixing minor errors and making calibrations and little corrections on the mechanism, this is the finish of my project. It is a little bit noisy, but at least it works very well. Thank you for watching me.